Welcome to the Impulse Spotlight, a podcast for product development professionals. In this episode, we talk to a polymer engineer whose upbringing in Brandenburg, Kentucky infused him with a spirit of exploration and love for music. He has a 5-octave singing range and grew up honing his skills playing trombone in various bands. Todd Cook is an R&D engineer for Cook Polymer Technologies. He works in partnership with Cook Medical Group to develop medical components used in minimally invasive surgical equipment. A scholarship from the National Science Foundation to study math modeling set him on the path toward engineering, but it was during his co-op experiences that Todd first discovered his passion for polymers. Todd's experience in polymer engineering has led him to develop products for industry giants like GE, Electrolux, and Remington Arms. Additionally, Todd, alongside his friend Paul Nash, co-founded Polymer eClub, an online platform dedicated to advancing polymer skill development with a focus on real-world application. In today's show, we discuss the Remington Supercell Recoil Pad and learn how Todd was able to recognize a winning idea that meets all the requirements of a successful product, from material advantages to market need. Todd's advice on navigating the twists and turns of product development is a goldmine for aspiring designers. From idea inception to final product, he's been through it all and has plenty of stories to share. Todd's enthusiasm for innovation is obvious, especially when he talks about the potential of AI in creating complex and effective product models. He's all about pushing boundaries and exploring new possibilities, but it's not all smooth sailing. Todd knows firsthand the importance of persistence and grit in the face of challenges. He's here to remind us that every setback is just another opportunity to learn and grow. Let's get into it. Hey, Todd, welcome to the show.
Thanks for having me, Troy. Appreciate it.
Sure. So a little over 25 years ago, after working for another product development company, I started Impulse. Kind of saw the writing on the wall that things weren't going to be around long there. So struck out on my own and been designing products in the product development field ever since. So how did you get into product development?
Yeah, it kind of accidental as well. When I was in college, I was looking for an opportunity to kind of develop my skill set, and I got a chance to go into the Edison program at GE, and there were a couple of rotations available. One of them was with R&D, and the GE R&D folks, that was their role, is to create new products for their businesses. And so I got into creating a new class of polymers and polymer composites with my first job. Got my first patents, and I was addicted. Like that, this is a thing that I like to do, and I'm going to try to figure out how to do it. And all these years later, I'm still doing it in a different way, but still doing it. So
what's your current role, and what kind of products are you developing right now?
Yeah, so I'm an R&D engineer for Cook Polymer Technology, which is part of the Cook Medical Group. They're a manufacturer of minimally invasive surgical instruments, and we provide, at CPT, we provide the components for those instruments to be manufactured. So if it needs a sleeve or cover or tube or hub or whatever, we manufacture those things here. And so I'm on the R&D team for that. So I'm the one helping to develop the material compounds, the product design details, drawings, all the ERP setup that's required to schedule components to be run, that kind of thing.
Okay. And tell us a little bit, I've been talking to you before, we're going to kind of shift gears, but tell us about the product that you want to talk about today and why you chose that product in particular.
Yeah, so it's my favorite story. If I'm going to tell people about product development and try to inspire them a little bit, I like to talk about the Supercell Recoil Pad that I developed for Remington. And the reason I do that is because it has all the ingredients that new product development, I think, needs. You have a market need. People are getting older, and these things are less comfortable to use. It'd be nice if there was some way to improve the comfort level. And so there are new materials technologies available. So there's another ingredient that goes in here. There's a new materials technology. As I told you, I'm kind of a Mustang addict. I've been fooling with Mustangs and old cars for a long time. And one of the first things you do when you get a Mustang, is an old one, is you take all the rubber components off of all the grommets off the suspension system and replace them with polyurethane, because the dynamic properties are better. And so you just go, I wonder if that applies to recoil pads, because recoil pads are rubber, pretty much traditionally across the industry. And so that's kind of how that seed got started. And then we just said, we're gonna take this as far as it goes. And there are ingredients to that, right? Your your listeners will appreciate this, I think, and I have had places where I have developed products that were cheaper, and I've had some successes and some failures with that. I've developed products that are better. They have some performance advantage, and I've had some successes and some failures with that. But when I have developed a product that performed better and was less expensive to make, I've never lost. That's a winner every time. And so if you can find the opportunity to do that, you should do it. And so this was one of those. Polyurethane is not radically different than other materials in its price, but you can foam that material. So you can put a foaming agent in it so that it reduces the density. So now you have a part that weighs less, which means you buy resins by the pound, but you make parts by the cubic inch, right? So if you can make something that's slightly less dense, then you can save money. And so if you can just imagine, this is a self-skinning polyurethane that has a foaming agent in it. So you basically have something like a seat cushion. It's completely integral skin, but it's foam inside, so it collapses. And as it turns out, you can engineer that collapse with the details of the polyurethane that you use and the amount of foam. And so that gives you that dynamic property that you want. And so you can engineer that. You can make some different versions and you can test them and find out which one works best. And the key there for me was finding a supplier that really wanted to work on the project, found it interesting, thought it had a fit for their business. They had a machine that they knew they could run it on if it worked out. And so they engaged, and that really helps too. So there's another element, that kind of thing to have is a supplier that has the skill set you need and has an interest in being able to make you successful. Because if they want to do it, they'll work at it, and I had some great help there. So you get the idea. I'm trying to sort of put together this package of saying, if you're going to develop something new, it's really great to have all of those: a market need, an obvious material advantage that you can take advantage of in the product, some feature or performance you can enhance, some way to reduce cost, improve performance for your client, as it turns out, a supplier that can do the task. And then finally, this is the hardest one, right? It's market acceptance. People have to use the product and go, man, this thing's great, and that's in Remington, you kind of had to get through the marketing team for that. These are the people that control what goes into the marketplace, because they want to control how they can respond to their key customers and so forth. They need if you will, a portfolio of options to respond to that marketplace. And you get to be one of those items in that portfolio by demonstrating something that they can showcase and that can get customers excited, get people buying things, and so on. And so they saw this, and there were things they didn't like, and so we made some changes, and we were able to get a product that we thought performed very well and had good long-term properties, which was another important piece of that puzzle. And it rolled out into the marketplace in several different SKUs. And the interesting thing to me is, even after the company has been through some turmoil, that product's still available, still on the market, still being used. And the comments that I see online of people using it is that they really like it, and I'm glad, because that's what this was all about for all of us. Really, was to be able to create something that people could use and enjoy. So.
Sure. For the listeners that might not know, what is a recoil pad?
Yeah. So if you think about a rifle or shotgun, Remington's classic, products, 200-year-old company plus, when you pull the trigger, a projectile gets pushed away from you at a high rate of speed, which means the gun comes back towards you. 200 years ago, it was a piece of brass on the end that was shaped as closely as possible to your shoulder to keep it from hurting. 50 years ago, that piece of brass became a piece of rubber. And people had fiddled around with that rubber. They put holes in it and did different things to it to try to change the dynamics. This would be, an integral skin foam. So an even softer viscoelastic response material with a pretty finish on it, so that it looks nice, represents the company logos and so forth well, but ultimately reduces pain. Because as it turns out, the force that can be measured in recoil is the key thing to think about. If you can reduce that, you can reduce the discomfort. And if you reduce the discomfort, people enjoy the product more, maybe they shoot more. That can be good for the company too. But anyway, that was the whole key, is people are getting older, their shoulders hurt more, they can't shoot as much. how could we help that? And that was the kind of the driver behind that product. So.
Sure. So you talked about longevity a minute ago. I mean, is there a life to how long that recoil pad can last? You know, so many shots, or is it
right? Yeah. So in terms of number of shots, maybe not, but yeah, everything dies of old age. If you see old rubber products, right, they get kind of glassy looking and they get these little cracks in them, and eventually they become quite hard. If you've ever tried to take a really old pencil and try to erase with it, it doesn't work anymore. It's so hard that it won't really work anymore. This material, polyurethane, the particular polyurethane that we use, is really one of the better materials for keeping its properties for a long period of time. And the reason for that is essentially that if you think about rubber, you get rid of the unsaturation in the chemical backbone of the rubber, right? It's got double bonds in it by nature, and you get rid of those by creating these cross links. You can create something quite dramatic in terms of its strength and also long lasting, but it won't be very soft and pliable, so it'll hurt when it hits you. So when you create the soft and pliable, you leave a lot of that unsaturation in there, and UV and oxygen in the atmosphere and so on take it away over time. So they get stiff and they don't work as well. This material is better for that purpose. And we've seen a number of people try to go into the marketplace with partially cured materials, things that are not fully cross-linked and they're quite soft, but the problem is they get sticky and gummy over time, and so they don't really hold up. And that's kind of the motivator. People want something that you can literally use a gun when it's 100 years old, and people want it to still work. And so we want to find materials that tend to last longer and do better. And so that's kind of the nature of that. So
sure, you've kind of touched on this a little bit, but we've helped people design thousands of products, and every journey is a little bit different. So can you kind of walk us through the journey of, like, you said you thought, well, the Mustang, what would that apply to the recoil pad? But what was the journey like, getting it from that idea to the shelf?
Right. So there was a design engineer that was working on a new shotgun program, and he really wanted a better recoil pad as a feature of that program. It turned out that we didn't dovetail because of the way that timing sometimes works out, but basically he was the one that said, hey, I'd like to try to find a way to do a better technology. Do you have any ideas? And of course that was the first idea. And he said, yeah, I've seen some high-end bike seats that have some gel materials and things, really soft materials on them. Let me get some samples and let's try to take a look at some things that are out there. We actually were able to find a manufacturer that had made one of those products and talk to them and get some, what I'd call slab sample materials, things that they make that are just a big sheet. You can just cut it whatever shape you want. And we did some testing with that and tried to play with that, and basically concluded it would not be able to be engineered to do what we needed it to do. In other words, it'll drop the force a little bit, but we needed to drop it dramatically where people could feel the difference or it wasn't going to work. And that's where you needed some part of the design to collapse immediately, and then the other part to collapse slowly. And so you go, what collapses immediately? Air. And so that's kind of how we got to the, let's put some cells in this thing and see how that goes. When we talked to the manufacturer of the materials, they were like, you sound like you're talking about something like this. And then they showed me something that was interesting but not relevant, as it turns out at the time, which was the earpieces for military headsets. Everybody's seen these kind of, I don't know what to describe them, kind of mint green with a microphone, and you expect to, in an action movie, the guy puts these on and he talks to the tower and so forth. And so
helicopter pilots got them on.
Right. That pad is a self-skinning polyurethane, but it's very low density for comfort. And so our quest was now, can that manufacturer make a density that's relevant for us? So we got together, had a meeting with them, and they were like, oh, yeah, we used to do a few things. And they brought out some samples of various parts for furniture and shoe soles and things that they had done, in their history. They'd never done anything quite like ours. And then he asked me, knowledgeable about guns and was a hunter, and he said, how do you keep the screws from tearing out of this thing? And I said, the same way we do the other ones, we'll put a rigid material inside that will handle the screw guidance and that kind of thing, and then you'll just mold over it. He's like, great. What do you think that should look like? And so I sketched, a basic idea. And he's like, yeah, we could probably make you a mold for that. So I said, well, great. We'll get you some CAD. You can send us a quote, that kind of thing. We built the first prototype, and he kind of fussed about like process issues. He said, hey, we got some things here we need to talk about to make the process better. Made some suggestions about how we would change it. Next thing you know, the prototypes they're easy to make. They run on the machine that he was interested in. His quote's really good. Marketing is in need of a new product to go on some things that are out there, and we could give them prices, and they were like, those prices? Yeah, we want to do this. And so, that's kind of how it happened. It ended up being 14 SKUs by the time we got it all done. But yeah, pretty exciting program from that point of view. But yeah, that's how it starts. It starts with an idea and a need somewhere. Somebody's got a niche they need to take care of. If you think about this material, and that, I'm not an advocate for just this material, right? I fool with all kinds of different polymers, but for this material, it's a great way to make grips and protection for things. If they've got to bump or do impact or interact with the body, really a great way to do it, because you can put the structure right into the mold and mold this thing right over it and get pretty good results. So I'm pretty excited about it.
Yeah, very interesting. What kind of timeline was involved, again, from kind of the beginning to getting it on the shelf?
Right, from idea to finished product, about 9 years.
Oh, really? Wow.
Wow. I mean, it really was a product that was in favor, and then people would decide that they wanted to go a different direction. We like this feature, we're going to co-market with this other product. Things, it would come into view for 3 months or 6 months, and then it would go out. The third time it came into view, it was, we don't have an alternative. We don't have another way to do this. You've got to deliver. You've talked about it. Now can you finish? And of course, by that time, we'd done enough research that we knew the performance characteristics. We knew who the suppliers were going to be. We knew what the designs had to contain. We had all of that worked out. So we were able to execute that third opportunity was our chance to shine. So that's one of those times when the third time really was the charm. But
yeah, that's really cool. So tell us about the team that was involved. How many people and what were the different roles that you needed?
Yeah. So, our group at Remington, I would call them, it was kind of a technology group. We had material science people. So I did polymers. We had a couple people do metallurgy. And so they would help you with those aspects of things. You would go to them for that. We had a FEA specialist who did what I call the textbook mechanical engineering stuff, doing the equations and making sure that the stresses were right and all that. And he was interested in recoil because he also was interested in the measurement technologies to measure it. And so he and I set up the measurement stuff together and did a lot of recoil testing through the years for various purposes, trying to understand how to do the measurements and how to get good information. And that good information helped because it ended up being in the advertising. So we could show that our product had better recoil performance than other people's products did. And so he was a key piece of that. Still around, we're still friends. I talk to him not as often as I'd like, but I still keep in contact with him. And he's still doing this type of mechanical engineering design and FEA and so forth. And then the marketing side, there was a person who was basically responsible for the product line that contained this accessory. And they were, he was very cooperative. And once it was clear that we had a set of characteristics that he saw a benefit to in the marketplace, like I can tell you applications where people want this, and if I show them that I can give it to them, I'm going to win a contract or win an opportunity. You're part of levering my strengths. Then they became very cooperative and did a bunch of testing for us, and wore their shoulders out on various things, trying to get the perfect design. So yeah, that was great. And then the other piece of it is the management. My manager at that time was very supportive of new developments that took the big risk. In other words, you can take a piece of rubber and change the shape, or you can change the way the logo looks or something. But that's not really a development. A development is really when you've got something that's new, that's never been done before. And he was willing to take those risks. And he would protect me from time to time when upper management would be mad that the schedule wasn't going to suit them and those kinds of things, because he knew, hey, we're taking risks here. We have to be willing to accept that it's going to fit on a different timeline. And because he provided that protection, we could do our work to get finished with all the details and really deliver a product that worked well. I mean, it's that combination. If you don't have that support, you can't do it. I literally talk about supporting innovators a lot in my work today because it's very important. If you don't do it, you won't get new things. You'll get the same old thing, and that's not necessarily what people are looking for. So.
Yeah. You may have just answered this, but with all the products we've designed over the years, there's always some kind of challenge that comes up. What was the biggest challenge you and your team faced, getting this developed, and how did you solve the challenge?
Right. So remember I talked about this starting out with a very, very soft material. And we picked a material the first time through that was not firm enough to do the job. Okay. Close, but not exactly right. And so you send those samples to people, and one person who did testing, if you've ever shot a shotgun, you know that you put the shotgun up here, so your hand is right there. If this thing comes back, you can pop yourself in the face pretty good. It's not a comfortable thing to have happen to you. And so you try to prevent that, but if you have a recoil pad that collapses too easily, perhaps that's what's happening. And this pad was worse because it was a little slick on the outside, so we ended up changing the finish to make it grip your clothing a little bit so it would stay in place. And so it slipped off, and he popped himself in the face. He wasn't very happy about that. But those are the kinds of things that can happen, and that'll derail a program because now everybody's upset. This isn't going to work. Well, sure. I admit that didn't work and wasn't a good experience, but the reason was that we didn't have the density quite right, and we'll go up a little bit, and we'll send you some more samples. And I'll do that testing ahead of time rather than send the first ones out to you guys, and then we'll go from there. And that's the way we worked it out, is to basically make sure the thing was okay. They ultimately, like I said, became champions of the thing, and it's been a success. Helped me with with the development of the branding and putting a name on it so that it would have something to be called out there in the market too, which is cool.
Yeah. You talked a little bit about prototyping with the manufacturer. Were there other types of prototyping processes that you used, like in the interim or while that was going on as well?
Yeah. So I didn't describe this in detail, and you can see it. This information is public record, right? Because you can buy these products, and there's a patent. But basically, there's a plate inside that is meant to carry the screw load, so that you can screw this thing onto the stock and it'll stay. And you have a cavity essentially above that the screw can go through, that's inside the foam, that'll still collapse, but you can't really feel it. If you're collapsing it all the way, you don't notice it. It just closes up and it's okay. But that had to be molded in. So that was all, figuring that out was a little bit of the trick. So we 3D printed the first ones of these. Okay. That did not work particularly well. 3D printing has come some distance. I think you can get better properties these days, but we had those things fracture in testing. And so what we ended up doing is the same person, the same manufacturer, was willing to take CAD and build a relatively cheap aluminum insert for a mold that he already owned, a mud mold that he already owned, so that he could mold us these parts. And we had to clip them, and we had to sand them a little bit, but we had a prototype that was more rugged, more like what we would expect the real product to be. And that worked pretty well. That got us through our prototype phase until we, in fact, to tell you the truth, it got us through our early production, because he used it for a while in production while we built the larger cavitation mold that he would end up using more formally in production. But we built the first few thousand parts for production using that mold.
So you got a prototype tool and a bridge tool out of it.
Right, exactly. And just really kind of worked out fine. And they were willing to do it. They had the materials there already. They made similar components. If you think about the handle or grip or cushion that goes on something, often you need a reinforcement somewhere to attach it. We're not the only ones that had that issue. That's a pretty common theme for them. So they had done enough of that they were like, yeah, okay, we can probably come up with that. And it turned out to be exactly true. They did.
Very interesting. So just a few more questions before we start to wrap up, and shifting gears just a little bit. What are some of the trends that you see emerging in product development?
Yeah, so I have some trends that I see as positive and some that I see as worrying. And I think I'll use worrying first, and then we can come back and cheer people up a little bit. The thing that I have that's worrying is that there are a number of people and a number of different pressures on some very useful materials, saying, for example, that they're not good for the environment, or that there's those kinds of pressures. Now, I'm an outdoorsman and avid so, and I think of myself as someone who loves the environment. But the reason why we convert things that we find on our planet into useful things for us is to help humans, right? To help people be better. And in some cases, it helps, our pets and so forth as well. But we do these things because that creates value for all of us. It makes life better and more comfortable and so on. So if you take those materials off the table for not a strong reason, you can cause harm. And I can give you a classic example. PVC, polyvinyl chloride, is a material that's in the news a lot. There was a famous train derailment, those kinds of things. PVC has some interesting properties. It plasticizes very well. It's relatively non-reactive, meaning the body doesn't respond badly to it. So it can be used in medical things and doesn't really cause big problems. Very commonly found in the products that are manufactured here. It also is really flame retardant and spark arresting, so that if you have some type of electrical overload or a switch that throws a spark, you don't have to worry about igniting this material. So you can make all kinds of products out of it that are safe and rugged and reliable and healthy. And if you get rid of it, there's no substitute. There is no material I'm aware of that can do what that material can do precisely. And as a result, if you lose that material, you lose those functions. And that, to me, is a serious problem. That can be a real threat. I mean, you could get to the point where some good products can't be made because you can't get the materials that you need to make them. And I just think that's a huge problem. Now, if I flip over to the good side, artificial intelligence, AI stuff, is really remarkably changing what can be generated. If you think about a frame to hold something, and you're going to, because of the style and the feature performance, you're going to machine that out of aluminum, let's say. You can literally develop models very easily that give you the perfect strength and weight combination. And it can be this very intricate three-dimensional design that it takes to do that, but it's generated in real time, and you generate the code right with it. And then you just cut the thing using very sophisticated code, but not code that was particularly hard to write, and get an absolutely beautifully performing product out of it. So there's this ability to personalize it, to make prosthetics, or to make products that fit people almost perfectly. You just go in and they take your picture with a scanner, and they tell you exactly what size of product you need, and they make you exactly the right adjustments for it. You can personalize and make products fit better. And that means performance will go up. You can cycle for longer, have more fun if that's what you're doing, or get better exercise if that's what you're doing, because the product fits you and is more comfortable, just as a for instance. So I see that as that's going to make products better. So I see that as as a really positive thing.
Sure.
I hope I did a good job with both up and down there. I hope I cheered everybody up.
That was very interesting. Rick, looking back on your experience developing products, I'm sure you've had a lot of challenges and successes. What words of wisdom would you share with those looking to make a significant impact in the product development industry?
Yeah, so mainly it's persistence, right? Always try to follow first principle when it comes to making a product, right? An early mentor of mine at GE Plastics, Ed Bostic, of happy memory, told me never to lie to the molecules. And I think what he meant was, don't kid yourself. You measure what you really get and follow it, because the data will drive you. And that's what you have to do. It's that kind of persistence is important. Every time you have a new idea, you're going to upset someone. That idea is not comfortable for everyone. It's going to cause problems. There's going to be issues. You can't make it. There'll be some problem with the design. Somebody doesn't like it. There'll be all kinds of things. If you stick to first principles, it's a good idea. It will serve customers well. It will create value, and you hang in there, you'll get it done. But if you don't have persistence, you won't. So you gotta be persistent. Be nice. Show people what it can do, but be persistent, because if you don't, new things won't happen.
I'd say sticking around sticking with it for 9 years is pretty persistent. So.
Yeah. I sort of laugh about this. I want to put this in here because, my first appearance on your podcast here, and I want to mention my dad. My dad was an inspiration. He was a teacher, and he had Alzheimer's, and so he kind of, for lack of a better description, kind of faded away. Mm-hmm. So one of the last things that I can say that he said to me that was in, recognizable English was never give up. Mm-hmm. And I thought, if you're going to have last words, those aren't bad ones. That's the real trick, the real power of what we know how to do as humans is to have a great idea and stay with it until we get it to work. And it's not easy, but it's worth it. And you've done this yourself a lot, and you've seen how many times persistence pays. I mean, if you don't have it, you won't get there because there's roadblocks in front of every good idea.
Yeah, definitely. Is there anything else you do within the product development world outside of your day job?
Yeah. So a friend of mine, Paul Nash, and I developed the polymer eClub. We had to use eClub because apparently Polymer Club was taken. But anyway, Polymer eClub is basically a learning opportunity. We make short format videos, long format videos, and we also have training courses in polymers for people that are interested. And what makes us unusual is it's application based. So in other words, we would not necessarily show you every synthetic route to get to a particular polymer as you might get in a survey course of polymers and that kind of thing, but really specific to application, just exactly in the same way I did the recoil pad. What polymer would be good for this purpose? Why? How do you make use of it? What processes do you use? What are the design considerations? All the stuff that it takes to really kind of put the thing into use in a real product. And we started about a year ago developing the website and putting together videos. And we have the sales funnel, if everybody knows what that is just literally on our plate here in the next few days to get launched. But the website's up. It's just polymereclub.com. And basically what we're going to be doing there is kind of four things. There'll be free content of interest on polymers. There'll be premium content, a little more detailed on polymers for members. Members can participate in a community where there'll be some webinars and also a chance to ask questions and get answers. And then there'll be coursework that's available for you to take, short courses that would compete with other kinds of short courses out there. And the whole effort is really aimed at getting more people more familiar with polymers so that they can use polymers more effectively in their product development and engagement. Paul works on the West Coast for a very large 2-letter manufacturer of computer and printer items. Has been doing that quite a long time successfully. And and I'm kind of in the center of the country doing product development, and most of the companies that I've worked for are brand names and recognizable. So I think we have some good experience to be able to share. And so far it's been a fun project to do, and I've enjoyed making videos and that kind of thing. So I hope it will turn out well for us. But that's basically the idea. If you want to learn more about polymers, come see us at polymereclub.com.
Yeah, that sounds very interesting. I'll put that in the show notes as well, and everybody can go check that out. So awesome. This has been great. I really appreciate you doing this. Before we wrap up, is there anything else you want to mention with regards to the product or product development in general?
Yeah, so the biggest thing that I would say is that if you are having some kind of frustration with some tiny aspect of an overall idea of yours, don't let it bother you. Reach out. There's so many people out there that probably already have the answer to that thing and would like to hear from you and work with you and that kind of thing. I find that I can knock away a lot of my roadblocks by finding a person who knows the answer, and they're out there and they're probably willing to talk to you about it and share with you about it. I know I am. So
yeah, those are good words. So before we end, where can people find out about the recoil pad? Yeah,
so today the website for Remington is www.remarms.com.
Okay.
And they can check out products that have it there. And you can also buy it as an accessory at your favorite accessory retailer. So.
All right. Cool. I'll make sure to put that in the show notes. And again, I really appreciate you doing this, Todd.
Absolutely. A lot of fun, Troy. Appreciate it a lot.
To learn more about Impulse and how we might be able to help you, visit impulseproductdevelopment.com.